Okay, expanding a logarithmic expression, problem type 2. Okay, so same rules as before, the last lesson, just these questions are a little more complex. So, first example is log of the square root of yz to the third over x to the fifth. So a square root means a half power. So I'm going to rewrite this. So we have yz to the third over x to the fifth to the 1/2 power. So there's a couple ways you can do this. The way I'm going to do this right now, and I'll talk about another way after, is move the half in front. So we have half log, put a bracket there, of yz to the third over x to the fifth. And now we have to break this up like we did before. So we have the 1/2. Okay, we have log y. Okay, y is multiplying z, so I'm going to go plus, because remember multiply turns into plus, log z to the third. And now x to the fifth is on the bottom, that means we're dividing, so minus log x to the fifth. Okay. So same thing we did last lesson. Now we can't leave these powers here, so it's 1/2 log y plus the 3 moves in front, 3 log z minus the 5 moves in front, 5 log x. And then Alex simplifies this, so we're going to get 1/2 log y plus 3/2 log z minus 5/2 log x. So I just distributed the 1/2 to each piece. Okay. So a little trick I use is anything on top is positive, so y and z cubed on top, so positive, positive. Anything on the bottom gets a minus, so that piece gets a minus. Just another way of thinking about the properties from last section. Another option you have is, some of you are thinking, well, if I distribute the 1/2 to each piece, you'll still get here, and that's correct. Okay, so you could start by distributing the 1/2 to each piece, skip this step and this step, and you'll probably just get here quicker. So you could simplify first, just be careful that you're properly simplifying. When in doubt, you can do it this way, but either way you come with the same answer. So if I distribute the 1/2 to each power, I will end up with this final answer. Number 2, log x to the fifth over z times the cube root of y squared. Okay. So it's a 3 there, the cube root of y squared. Okay. So remember, the cube root of y squared is going to be y to the inside over outside, 2/3. So the power over the index, but I just go inside over outside. So I'm going to break this down. I'm going to go, so this whole thing isn't raised to the power like the previous problem over here. So I'm going to go x to the fifth is on top, so it gets a positive. The z's on the bottom, so it's going to get a minus. And then this cube root of y squared is on the bottom, it gets a minus. It's going to be y to the 2/3 because of what we already explained. Now just move the power in front and you are all set. So on top, positive, bottom, bottom, both negative. At the end, move any powers to the front. This is different than the last problem because this whole thing was square rooted, so the whole thing raised to the half. This one here only has a funny root. So another style, they're all similar, but they have subtle differences. Log of the cube root of x to the fifth y squared z. If you want to pause it and try it, go ahead. I'm going to continue on in a second. Alright, so there's a couple different ways you can do this. So everything in here is being raised to the first power. There's no power, additional power inside, which you won't see. So this is x to the fifth y squared z, and the cube root means 1/3, because technically this is all raised to a 1. Okay. So cube root is 1/3 power. Square root is 1/2 power. Now, you could distribute the power or do it the other way. It doesn't matter if you have to do it the other way. So 1/3 log x to the fifth y squared z. Alright, now we gotta break these apart. So leave that 1/3 there. We're gonna go log x to the fifth. So they're all on top, so they should get addition signs. Plus log y squared plus log z. So we get 1/3. Bring down that 5 in front. Bring down the 2 in front. And there's nothing there. Finally, distribute the 1/3. So 5/3 log x plus 2/3. So 1/3 times 2. 1 times 2 is 2. 3 on the bottom. Log y. 1/3 times 1 is 1/3 log z. Alright, so that is a few scenarios of the problem type 2. They are more complicated. Oh, going back here, if we distributed the 1/3, you would still get the same things. You get 5/3. There's your 5/3. 1/3 times 2. There's your 2/3. 1/3 times 1. There's your 1/3. So if you distribute the power to a power, you multiply, and then do it out, you'll get the same thing. Maybe a step less or so. It just all depends. And if you can jump from, you don't have to do this middle step here. If you can jump from here to here, that's fine. Or if you can move the 5 down, the 2 down, all in one step, that's fine. You can combine some steps here. I'm just showing you all the steps for notes.